Look at the weight of a body inside a lift. Okay, a man standing in a lift or an elevator has two forces acting on it. A man standing in a lift or an elevator has two forces acting on it. The first is his weight, and the other is the normal reaction on the floor, on the man acting upwards. Okay, the normal reaction. Of course, when you stand, there are two forces. I think I have done a video on this, especially friction. When a man stands, his weight is acting downwards, but there's also the weight which the floor, or there's also a force the floor exerts on the man, and that is called normal reaction R. Okay, that normal reaction is the reason why the man did not sink, So I start again. A man standing in a lift or an elevator has two forces acting on it. The first is his weight, and the other is the normal reaction of the floor on the man acting upwards. Okay, weight always acts downward, but the normal reaction acts upwards. Now, the weight of the man is varies varies depending on the movement of the elevator. Now, when the elevator is moving either upward or downward, and the weight of the man is checked, is not the same. Okay, so let's look at case one. Case one: when the elevator is not moving or moving with a constant velocity, the resultant force acting on the man is zero. So the true weight of the man is measured, and you can see here that Fr, which is the resultant force, R minus mg equal to 0. That's in case one, when the elevator is not moving. In that case, the normal reaction is equal to the weight. So the normal reaction is equal to the weight only when the elevator is not moving. Okay, but case two, when the elevator is moving upwards, okay, actually you'll be feeling heavier. You know why? Because you are moving against gravity. But let's look at this. So the resultant force here, because it's moving upwards now, we are going to have R minus mg, okay, which is the resultant force, is equal to ma. Okay, we don't even need to call it R. Maybe you say R1 because there is a force pulling it upward. It's bigger than R itself. So we said minus mg equal to ma. So R here will be equal to ma plus mg, which is m into a plus g. So hence, the apparent weight, good. The apparent weight will be equal to mass into a plus g. That means it will be heavier, to be plus. Case 3, when the elevator is moving downwards, of course, when you're moving downwards, you're moving with gravity, the weight will reduce. Your apparent weight will reduce. So we are going to have mg minus r equal to ma. Mg minus r now, because it's going downward, this is supposed to be mg. It's supposed to be mg minus r equal to ma. Now, this r is not just any r, it's apparent weight. So let me call it r2. Okay, not just the normal reaction, because it is not the normal reaction carrying you up. Okay, so in this case now, my R2 now is equal to mg minus ma, so which is equal to m into g minus a. So the negative sign means that as the elevator is moving down, the weight, your measured weight, will be smaller than your actual weight because you are moving with gravity. But when the elevator is moving upwards, the measured weight will be a little higher than your real weight because you are moving against gravity. Okay, now let's see a question here. Here it says, what is the apparent weight of a man of mass 10 kilograms in an elevator when I, it is moving upwards, then I, it is moving downwards with an initial acceleration of 5 meters per second. Okay, that's quite simple. This is the apparent weight when it is moving upwards. Moving upward means it's heavier, so mg plus a. So your m, mass, is 10, acceleration due to gravity is 10. The acceleration of the elevator is 5, so 10 plus 5 is 15. 15 times 10 gives us 150. The apparent weight when moving downwards, it will be mg minus a, so 10 minus 5 is 5, 5 times 10, 50. So that is how we got this. Then the next here says a body weighing 80 newtons stands in an elevator and is about to move. The force exerted by the floor on the body as the elevator moves upward with an acceleration of 5 meters per second square is, that's still talking about the apparent weight. Okay, so since it is moving upwards, it means that your apparent weight, which is W, will be equal to, in this case, moving upward means it to be AVR, that means M into G plus A. So your M here, your mass, we are not given mass, but from this 80 newton, is weight 80 newton, it means that the mass is 8 kilogram. So your mass here will be 8 into your G is 10, then plus this will be 5. Okay, that is equal to 8 times 10 plus 5 is 15. That will be 80 plus 40, that will be 120 newtons. So the answer to this question is C. Okay, that is very, very important. Thank you very much. We have come to the end of Newton's laws of motion.